welcome to CEC Gurukul lecture. In the continuation with the series on sociological research method, in today's lecture we are going to discuss on statistics and sociology. Now we know that sociology deals with a large scale phenomena in which there is a lot of effort to understand certain rates like suicide rates or the rate of literacy and the decline or increase of divorce, marriage, etc. And for this, quantitative data are extremely handful in understanding the phenomena of. So, in the first half of the lecture, we discussed Raftery's article, that is sociology, statistics in sociology, and we referred to the three generations of statistical method: the first generation, the second, and the third. In first generation, we have discussed the ways in which cross tabulations were used to understand mobility and the migration and the rate of change. Now, in this second half of the lecture, we are going to concentrate on the two other generation, that is the second generation method and the third generation method. So, the second and third generation methods in Raftery's scheme are the backbone of contemporary quantitative sociology, shaping how most large research is done today. Second generation method grow out of regression analysis applied to unit level survey or census data, and this enabled by computers and large national data sets from the 1960s onward. Core tool included multiple regression, logistics, and multinomial regression, event history or survival model, and the structural equation or LISREL models for latent variable and causal pathways. Third generation methods extend beyond independent, identically distributed unit level data to handle complex structures and dependence. This generation includes multi-level hierarchical models, social network and spatial statistics, and approaches tailored to emerging data types such as contextual, longitudinal, or text-like data. These methods are crucial for questions about context and structure, neighborhood and school effect, organizational and country differences, diffusion in network, spatial clustering, and cross-national comparison. So, let us first try to understand the different levels of data analysis, use of statistics in the second generation, and then we will look into the third generation. So, when we look into the second generation statistical methods in sociology, we understand that it emerged in response to the availability of unit level survey data. So, with large rectangular survey data set, many respondents into many variables, sociologists turn to linear regression and extensions such as path analysis, structural equation models, generalized linear models, and event history model to study relationship among variables. When the aim was to describe entire distribution rather than predict mean outcome, non-parametric methods were developed and applied. So, one of the important study of the second generation statistics was to understand occupational status, because again going back to this what we already discussed was the emergence of sociology as a discipline at the time of industrial crisis, and therefore there were a lot of focus on studying occupation, mobility, migration. So, when an occupational status was measured by the use of statistics. So, why was it important to measure occupational status? Because occupational status is an important concept in sociology, and developing a useful continuous measure of it was a signal achievement of the field. Initially, the status of an occupation was equated with its perceived prestige as measured in survey. However, surveys could measure the prestige of only a small number of the 800 or so occupations identified in the census. To fill in the missing prestige score, Duncan in 1961 regressed the prestige score for the occupation for which they were available on measure of the average education and average income of incumbent of the occupation. So the Duncan developed the socio-economic index to understand the occupational status. He found that the predictions were very good. R2 is equal to 0.91 and that the two predictors were about equally weighted. Based on this, he created a predicted prestige score for all occupation, which became known as the Duncan Socioeconomic Index. The resulting predicted values formed the Duncan Socioeconomic Index showed excellent fit to observe prestige around 0.9 explained variance and later proved to predict a wide range of social outcome even better than the raw prestige index. So, why are we trying to understand occupational status or why occupational status is preferred? Occupational status via socioeconomic index and its update is widely used because occupations are measured more reliably than income or wealth, which suffers from non response, recall error, and instability. Status scores are relatively stable over the life course and across generation and show strong cross-national and temporal consistency, which is known as the Tryman constant, making them good indicators of long-term or permanent income and of stratification position. The status of occupation tends to be fairly constant across different countries and over time. Now let us discuss the different models which were used for use of statistics and sociology. One of them is the path model, occupational attainment. The foundational work was the basic path model of occupational attainment developed by Blau and Duncan 1967 and analyzed by Duncan in 1966. This approach originated with Wright and was given a causal interpretation in the social sciences by Blalock. Often the variables of theoretical interest in a causal model, the constructs such as prejudice, alienation, or ability, are not observed directly. Instead, researchers observe other variables that serve as their measurement. Now, the next model is the structural equation model. Joreskov's solution 1973 introduced structural equation model with latent variable using maximum likelihood estimation. This is often called the LISREL, that is linear structural relation model, and this model is termed after Joreskov's software. What is the structural equation model? Which basically this tradition formalizes into two main parts. One is the measurement model. This part links observed, that is measured or manifest variable, to unobserved latent variable or theoretical construct. It is a form of confirmatory factor analysis that account for measurement error, an advantage over traditional methods like multiple regression. The second model is the structural model. This part specifies the hypothesized causal relationship and direct indirect effects among the latent variable themselves, often represented by path diagrams. Moutain extended the LISREL type model to include categorical indicators and later showed how similar structures can represent longitudinal trajectory, growth curve, and multi-level hierarchical data. Graphical Markov model, specified via conditional independence rather than regression equation, provide another way of representing complex multivariate dependence. The third method that is used in the understanding of unit level data, that is the second generation method, is the event history analysis. So, unit level survey data often include or allow the reconstruction of life histories. This include the times of crucial events such as marriage, divorce, birth, committal to and release from prison or job changes. Social science event history data are often recorded in discrete time. Example, by year, either because events tend to happen at a particular time of a year, for example, graduation, or because of measurement constraint. As a result, discrete time event history models have been popular and in some way are easier to handle than the continuous time analogous data. One problem with social science event history data is that dropping out can be related to the event of interest. For example, people may tend to leave a study shortly before a divorce, which will play havoc with estimation of divorce rates. The basic trick is to observe that although one does not know which of the people who dropped out actually got divorced soon afterwards, one can estimate which ones were more at risk of divorcing. So, the different ways in which the event history analysis can be used to understand the course of life events in individual's life, and that also will reflect on the socioeconomic changes that was taking place in the society. Now, with this, we come to the third generation methods. Now, the third generation methods is kind of from 1980s onwards and more in the contemporary context, and therefore, a number of advanced methods are used in statistics. Some of them that has been discussed by Raftery in the articles are social network and spatial data, textual analysis, narratives and sequence analysis, stimulation model, and then the growth of the macro sociology. Social network and spatial data is the first method that falls into the third generation method of statistics, and the network here is kind of a number or group of individuals networked because of certain kind of similarity or familiarity, and the example could be friendship between adolescents or political alliance and pattern of marriage between social groups. These are some of the networks that can be taken as example. Frank and Strauss, that is 1986 published work, developed formal statistical model for such network related to the Markov random field model used in Bayesian image analysis and derived using the Hammersley-Claude theorem. This has led to the promising P class of model for social network. Methods for analysis of social networks have focused mostly on small data sets with complete data. In practical applications, however, the data tend to be very incomplete and current methods are somewhat at a loss. This is the stage that pedigree analysis in statistical genetic was at some years ago, but the use of likelihood and MCMC methods have led to major progress since then. Social networks are more complex than pedigrees in one way because pedigree tend to have a tree structure while social network often have cycles, but progress does seem possible. So, there is a shift from pedigree to more network analysis, and most social data are spatial, but this fact has been largely ignored in sociological research. More extensive use of spatial statistics in sociology seems likely, and therefore, we move to the second category of data in third generation research statistic method, and that is the textual data in sociology. It includes interviews, open-ended survey responses and ethnographic field note. These pose hard problems for formal statistical analysis, and most existing methods still rely on relatively simple forms of content analysis. Traditional content analysis usually codes or count words, categories or themes in text and then analyzes those counts statistically. Such bag of words approaches often ignore the order of words, grammatical relations and narrative structures, so they lose much of the contextual information that carries sociological meaning. So, because of the limitation of the textual content analysis, they are new promising new approaches. So, the current focus is on developing method that incorporate the context of language The examples of more promising approaches are Carley's published 1993 map analysis. Likely involves using mapping relationship between concepts or actors mentioned in the text. The second new approach is Franzosy 1994 set theoretic approach, a method for translating qualitative statements into formal set theoretic proposition for analysis. The third is Roberts 1997 generic semantic grammar, an attempt to analyze the underlying meaning and structure of the text beyond mere word counts. So, there are a lot of progress in the way in which textual data is used in the quantitative method. And in the next part of the article, Raftery notes that only the surface has been scratched, implying that these methods are nascent in quantitative research. They are more like textual or content analysis are more developed in the qualitative analysis. So, when the analysis of textual data is likened to other complex problems like image analysis, speech recognition, where the human mind excels, but the computer struggles with the nuanced context and inferences. Information retrieval from the web, that is, use of the search engine, faces a similar massive challenge and primarily relies on simple content analysis. The more contextual method being developed in sociology could potentially be useful in improving web search capabilities. So, when we look into the use of textual data in statistics, there is this intriguing case of blending the quantitative and the qualitative data. So, basically when we are reading text or content, it is qualitative, but the way when it is translated into numbers or quantitative, the two methods are being used, which is kind of also referred to the mixed methods. So, Singer, Rivkar and Maggie 1998 published work demonstrated an intriguing blend of the methods. They started with a standard unit, that is label data set, which is quantitative, with over 250 variables per person. They converted this quantitative data into written biography or textual data. They then examined the biography for common features and thinned them to more generic descriptions, qualitative textual analysis. This example highlights the potential for methodologies that bridge the quantitative and the qualitative divide. The third method, which is part of the third generation statistics method, is narrative and sequence analysis. Narrative and sequence analysis is a methodology in sociology specifically arguing for the holistic study of life history using technique adapted from molecular biology. Life histories, that is example professional career, are typically analyzed by number one, reducing them to variable for regression and multivariate analysis, and number two, using event history analysis. Abbott and Hyrak argued that many vital aspects of careers or biography only become visible when the whole sequence of state is analyzed as a pattern. They proposed viewing careers analogs to DNA or protein sequencing and applying optimal matching, that is, sequence alignment algorithm that count the minimal cost of insertion, deletion, and substitution needed to transform one sequence into another. Once pairwise distances are computed, cluster analysis can be identified typical sequence pattern. Stove, Savage and Bierman, these are names of scholars, they use strategies to study how career system of Lloyd Bank changed over the 20th century. So, this is an example of the use of the quantitative qualitative blend. Now, when we can use these methods, is also question of extensions and open questions, adding covariate. Disgrater and Taris 1995 extended the co-idea to include independent variables or covariables in the sequence analysis framework. Gibbs sampling is another technique. Abbott and Barmar published 1997 work applied the Gibbs sampling sequence detection method also originally from microbiology, which proved to be very effective for identifying shared pattern or motive within a set of sequence. Raftery concludes that this is a very interesting approach with many open statistical questions, indicating it is a growing area of research. The next method within the third generation statistics is simulation model. Simulation models in sociology use mathematical representation of interacting compartments or agents to explore how micro level behavior generate macro level outcomes in areas like war, collective action and disease spread. They are often deterministic and complex, representing social system through number one, different compartments that interact with one another, and number two, each compartment is defined by a set of different or difference equation that governs its change over time. How are these models used in sociology? So, these models have been used to explore the implication of different theories in various domains. The interaction between domestic politics and war. Example of such work is from Handman, Collins and Mott, published in 1995. The social dynamic of collective action is another application in sociology, and the authors are Kim and Bierman, published in 1997. Another work published in 1997 is by Morris, and they look into the role of sexual network in the spread of HIV. Now, despite their promise, these models, that is the stimulation model, often involve many poorly identified parameters, and there is no fully standardized way to estimate them from data. So, basically when we look into the use of application of statistics in sociology, we also need to understand the challenges with statistical inference. A major drawback of the stimulation model is that the method for statistical inference are not well established. This includes number one, estimating the many parameters involved, number two, assessing the fit of the model to real world data, number three, comparing competing simulations model. These tasks tend to be done by informal trial and error, and therefore we need to look into the future direction of simulation error in statistics and their methods developed in other disciplines to put inference for complex simulation model on a solid statistical footing. The last technique classification within the third generation is macrosociology. Raftery describes macrosociology as dealing with large entities such as state and the interaction, and with highly aggregated outcomes like fertility, mortality, economic growth or war. At this level, theories are typically broad, qualitative and underspecified, which makes it hard to translate them cleanly into statistical model. He argues that sophisticated tools for handling model uncertainty such as Bayesian model, averaging and systematic comparison of the alternative specifications are especially important for quantitative macrosociology. So, what are the proposed solutions for the kind of challenges of inference in statistics? And Raftery outlines three main responses to the small n problem in macrosociology. Number one, qualitative comparative analysis or QCA, Ragin, also known as Ragin alternative, and it is kind of explained as a logic based and focus on your necessary and sufficient conditions for an outcome. This approach has been criticized because it does not allow for variability of any kind. This makes the QCA highly sensitive to small change in the data or in the application of the method. The another problem is strategy proposed solution by Raftery is to increase the sample size. One straightforward solution is to find ways to obtain an at least moderately larger sample size, and Bolin and Applaud 1993 published work successfully accomplished this in their work. This is not a general solution because by definition the number of macro level entities is often fixed and small. The third solution to the challenges of macrosociology is the Bayesian method. When increasing the sample size is impossible, another approach is to use standard regression type model, but employ Bayesian estimation. This is especially effective when there is a strong prior information available, which is common in macrosociology due to the practice of analyzing specific case in great detail, and this has been referred in the work of Weston and Jackman 1994. Bayes factor are also helpful because they tend to be less stringent than the standard significance test in small sample, and number 2, provide a calibrated assessment of evidence rather than forcing a simple accept reject decision. So, when we have discussed the 3 generations of statistical method from 1940 to the present situation where new models and macro sociology level data analysis has been done, we need to understand the level of achievement of sociological statistics. And one that is kind of very significant is that statistical methods have transformed sociological rigor over the past 50 years, and that institutional investment in social statistics are now consolidating this progress and opening new research fronts. So, what are the achievements of sociological statistics? Sociology has been instrumental in number 1, leading the way in providing models for cross classification, that is log linear and association models. Number 2, developing well adapted methods for unit level data set, that is SEM, event history analysis. This success has contributed to greatly improved level of scientific rigor in sociology, and kind of makes it more to be taken as a serious research work. So, what are the future outlook and institutional investment? The field is described as ripe for statistical research due to abundance of new kinds of data and new challenges such as textual sequence and complex simulation data, which we have already discussed. So, several major academic institutions are launching or strengthening efforts in this area, signaling a recognition of the field importance. Number 1 is the University of Washington, established a new center for statistics and the social science. Second, UCLA, their new statistics department grew out of the social statistics. Third, at Harvard, the new center for basic science research in social science emphasizes social statistics. So, efforts are underway at the University of Michigan, Columbia University, Santa Barbara, and the University in North Carolina. So, there are several institutes being developed to focus the use of statistics in sociology. So, the most kind of understanding from the second and third generation is that the second generation methods still form the standard toolkit for analyzing relationship between variables in stratification, education, health, fertility, and labor market research. They underpin most current practices based sociology and are deeply embedded in statistical software training and publication norm. In contemporary sociology, they are central to policy relevant research and comparative work, and increasingly intersect with data science and computational social science, making them especially significant for current and future methodological development. So, by looking into the understanding of the way in which statistics has been used, we need to understand the significance of statistics on sociology. For reference, the entire lecture is based on the reading by Andrew E. Raftery, published in 2000, Statistics and Sociology, 1950 to 2000. The article is published in Journal of the American Statistical Association, volume 95, number 450. It is important for understanding this lecture to read this article. With this, I come to an end of this lecture. Thank you.